Hi guys, let's solve today's Leetcode problem, which is problem number 3120. Count the number of special characters 1. It's an easy problem. You're given a string word. A letter is called special if it appears both in lowercase and uppercase in word. Return the number of special letters in word. So in this example, if you see, for A, we have both small case and uppercase. For B also, there is both lowercase and uppercase, and same for C. It has both lowercase and uppercase. So for this particular word, the answer is 3 because there are 3 letters in this particular word which has both lowercase and uppercase. Now, if we check for this example, here all letters, whatever are there, lowercase is there, but uppercase is not present. So for that reason, answer is 0. Okay. Now let's see the constraint. Word dot length is 50 only. So any like brute force approach would work. And this word consists of only lowercase English letter and uppercase English letters. Okay. Though the constraint is small, but the approaches that we are going to cover, we are going to understand what is the different time, the small differences between all the approaches that we are going to cover. So that is the basics to understand. So we will cover brute force approach using set data structure, then using Boolean array, and then bitset, and then compare the differences between the time that it takes. Let's get started. So brute force approach is nothing but we have to check for each characters. That is, there are 26 alphabets, right? So we have to check for each of these, and if it's upper and lower case, both value exist in string or not. Okay, and then we have to count accordingly. So if we see this example, when we get started over, so this is our string given to us, and this is the number of alphabets that we have. So when we get started with 0 till 25, which means 0 means we are checking for character A and small and uppercase both. Okay, we are checking for these. Okay, if this exists in our string or not. So this is our first iteration that will happen. Check if this index I plus this value A is equal to this value or not. So we will iterate on this word one by one, and we will check if this is equal to this or not. Okay, if it is equal to this value. Okay, so if it is equal to this value, the characters in this word, then we will mark this lower, that we have found the lowercase. Okay, now if this character is equal to this uppercase, basically this value, which means that we have found our uppercase. And at any point of time, if we have found both lowercase and uppercase for this particular index, okay, okay, for this character A we have found. Okay, so we will break from there and we will count into our answer. Otherwise, we will iterate over all these characters in this word. And same thing we will do for all these indexes, basically for all these alphabets. Okay, so we are picking a alphabet in this 0 to 25 index, and then we are checking if both lowercase and uppercase exist in this word or not. Okay, so that is the approach. Now let's see the code. So code is, we have this count variable, then n is word dot size. Now we are iterating on this 26 alphabets that we have, and we have taken this variables has upper or has lower in the string or not. And here we are iterating over the string word that we are given to us, and here we are checking if this word of j is equal to a plus I, which means that this word character that we are checking, it is equal to small case of this I or not. Okay, if it is, which means that we have found our lower case for this particular I, and otherwise we are checking if this is equal to capital A plus I or not. If it is, then we have found the uppercase of I. Okay, so if at any point we have found both lower and uppercase, then we can increase our counter and we can break. Why break? Because for this particular index we have found our answer, right? So nothing will increase for this counter. So basically, if you are looking for, let's say, character C, so if we found both capital C and small c exist there, then no need to further find it, right? Because there will be no further count. We can check for other characters for of other alphabets basically. So we can break, and at the end we can return the count. So if we see the time complexity, so it is nothing but we are checking for all these 26 alphabets into our string, and string is of length n. Okay, so at max we will be iterating or 26 into n times. And space complexity, if we see, so it is O of 1. Okay, so that is about this. Now let's check the next approach. Next is using hash set. So we will use set data structure to store all the characters of string and then traverse on the 26 letters and check if both lower and uppercase exist or not. Okay, so when we will iterate on this example, what we will do, we will add these characters into set. So how it would be? It would be B, B, C, and then capital C. All these characters are inserted into set data structure. Now we will iterate on these characters from A to Z, and we will check for both small case and uppercase if this exists in this in this set or not. Okay, so when we check for small a, it exists. Then we have to check for the capital A also, that also exists. Okay, which means both small and capital A exist, so we can increase our counter. Okay, is equal to uh, it was 0 initially, now it is 1. Now we will check for B. So for B also we found the small and uppercase both, so we will increase our counter to C. Now we will check for C. So for C also small and uppercase both exist, so we will now increase our counter to 3. Similarly, we will check till index, I mean this character Z. Though none of the further characters exist, so our answer is 3 only for this case. Okay, but these are the two things that we are going. Now let's check the code for the same. So if you see the code, we have declared an unordered set of characters, and we have added all the words characters here in the set, that is using this word dot begin comma word dot end, and then we have this counter variable. Then we are iterating on this character A to Z, and we are checking if S has this count C. C means this is small case, right? Which means lowercase exists, and S dot count C minus A. So C was initially lowercase. Okay, so and minus A will give me the uh, difference between them, and if I do plus of A, okay, so which means that will give me the uppercase uh, value. So I have to check if this will give me the uppercase value for the C. Okay, so I have to check if this also exists or not. If it exists, then we will increase our count, and at the end we have to return the count. Okay, so this is about this. And if we see the time complexity, so here we are inserting all the characters into our set, so that is O of n. And here then we are iterating on this 26 alphabets, so that is 26 altogether, since length is n and we are inserting, so it will be O of n. And inserting into set data structure basically. Okay, and then space complexity is O of n. Okay, because we are inserting all the characters here, and also the characters will be only lowercase and uppercase alphabets, right? Which means A to Z and capital A to Z, which is 26 plus another 26, which means 42, right? So space complexity is nothing but I can say O of 52, which is more or less a constant space, I would say. But yeah, I mean, space is constant throughout this problem. But if we see, this is O of 52, and there is definitely the uh, hashing and other things involved with the set approach. Okay, so that is additional overhead, but the space complexity is O of 52 here. Now let's check the another approach. So another is using the Boolean array. So what we can do, we can have this Boolean array to track the presence of both lower and uppercase, and then we can count if it has both or not. So when we start here, so a, then for lowercase a, so marking is nothing but this a minus a, right? This will give me the index 0. So I will mark this as true. Okay, then for a small a, the same thing, capital A. So for capital A, I'll mark the uppercase boolean array. Okay, so it will be true. Similarly for b, also we will mark this as true. For capital B, we'll mark this one as true. For small c, we'll mark this as true, and then this as true. Now what we have did, we have marked the presence, okay, in this lower and uppercase array. Then we will check, basically we'll iterate on this, that is on this 26 alphabets, and we'll see if both lowercase and uppercase are true or not. Okay, if both are true, which means we can increase our count. Okay, so now let's check the code for same. So here we have declared two array, lowercase and uppercase of size 26, initialized with value false initially, and then we are iterating on this characters, each characters of the word, and we are checking. Uh, so here what I did was C is greater than equal to A. So you know the ASCII value for small a is 97 and ASCII value of capital A is 65, right? So if the C is greater than equal to A, which means that it will be only small case characters only, right? So what we will do, we will update our lowercase values accordingly. That C minus A, we will mark this as true. This will give us the index. Otherwise, if this is not lowercase, which means it's uppercase character, right? So we will update our uppercase array, Boolean array to true for that particular index. Okay. So we have marked the presence of each of these characters in our string words of this character. Okay. Basically all the characters of the word. Now what we need to count, basically iterating on this Boolean array and checking if this has both lowercase of I and uppercase of I is equal to true. Okay, if both are true, which means that it both exists, so we can increase our count and return at the end. So if we see the time complexity, so this is O of n. Okay, so it is O of n plus another O of 26. Okay, and same is for above also, right? Initially we were inserting the value into set, that was O of n, and then iterating and checking, that was O of 26, right? More or less we can say that this is O of n only. Now if you see the space complexity, so it is O of 2 times 26, I would say. Okay, because 26, because these lowercase and uppercase characters, this boolean array is of size 26. Okay, and now also one more thing is the how this approach is little different from above approaches. Basically set comes up with the hashing thing and the nodes that we store in the set and the bucket it uses, all this kind of things, right? So a set has some hashing and other things, complexities involved to store all the values, so that all unique values can be stored in set. Though since this only contains lower and uppercase characters, so we don't really need that complexity, and this is simple and straightforward. We can directly track the indexes, so we can use it. Okay, so space complexity is still lesser than set. uh, Maybe this is very small difference, but this is still less. Okay, now let's check the another approach. So another approach is using bitset. So what we will do, we will use two bitset. Basically, bitset is nothing but a container in C++ to track the presence of both upper and lower case characters, and then we will count the common set bit. Okay, so this is the string, and for each of this character, what we will do, we will mark their presence in this lower and upper case bitset. So for A, since it is small case or lower case, what I will do, I'll update this value. So C, this A, this, right? So I'll mark this as 1. Okay, basically I'm setting this bit. Okay, so this, there are 26 bits in this value, so I am setting this first bit. Now for this one, basically, so this is nothing but 25. Okay, now for this A, again same thing. For this A, this is capital, right? So I will set this bit. Similarly for other bits also, I will set these bits every time. So after setting all this bit, what I will do, I will use this bitwise AND operator. Okay, so since these are bits, right, I can do a bitwise and the final answer that I will get after doing AND will be something like this. Okay, which means that after doing AND operation, it tells basically both the values should be 1, right? Here, if any of the values are 1, let's say here it is 1, here it is 1, but eventually if you will do AND, this will be 0, this will be 0. Why? Because for AND operation, both need to be 0, right? We will do the AND operation, and then we can count the number of set bits over here. Okay, so that is the bit set approach. Now let's check the code. So we have declared two bit set container, upper and lower of size 26, and then we are iterating over the characters of word, and there is this is lower C++ STL also, so we can use this. I mean, this function is there. So this will tell me if this character is lowercase or not. If it is lower set, then I need to set the bit of this lower bit set. Okay, this lower bit set I have to set. So lower dot set c minus a is giving me the index for that particular bit set. And so I'm setting, if the character is lowercase, then I am setting the bits of this lower bit set. If it is uppercase, then I'm setting the uh, bit of this upper bit set. Okay, and after the bits are set, basically we have marked the presence. Now what I'm doing lower is equal to lower and upper. Okay, so eventually lower will contain all the you know places where both upper and lower are equal to 1. Okay, so this is what AND operation will do, and at the end we can count the number of set bits. So using the same C++ stl dot count method, we can count the number of set bit in this lower bit set. Okay, so this will give me the final count. Now if I see the time complexity, so it is O of n, as I'm going over this, and then tracking all the values in the bit set. Then this AND operation is nothing but a unit operation. Okay, this is a single operation. So this is a single operation, and counting the bits, you can say like it is O of 26, basically checking all of this bit set. So time space complexity, if we see, so it is O of 26 again, which is eventually O of 1. Okay, now if we compare this approach and the Boolean array approach, the difference is that Boolean array, the size of Boolean uh, in C++ is 1 byte. Okay, and for bit set, each of this bits, 26 bits, so it is 1 bit, so it will store 26 bits. Okay, so 26 bits, but this will take 26 byte. Okay, in the memory. So this is definitely a more efficient approach, and this is always the case that the bit set approach or the bit manipulation approach is always faster. Okay, so we should know about it. Yeah, that's all about this approach. Thank you for watching. Stay tuned for next videos.